Hello! It's time for us to take a look at the one workshop that we have for today. And this workshop really is just a demonstration. We want to walk you through some material that will help to demonstrate for you many of the OWASP top 10. Of course, you don't need to be able to do these things yourselves or exploit a web application, certainly not as a security manager. But if you're looking at a vulnerability assessment report, or if you're looking at a penetration testing report or other assessment that's detailing kinds of findings, you should absolutely know what those findings mean. And what we find, at least what I find personally, especially working with court cases involving United States regulators prosecuting organizations for cyber breaches where web applications have been involved, I find quite frequently that there have been assessment reports done, but the security managers and the developers have no idea what those reports actually mean and end up downplaying the results to senior management. Obviously, this is very bad for the company, but it's clearly also very bad in terms of a career. So we want to make sure you know what these things are instead of just having those raw descriptions that we've got in the text of the book. While those are quite thorough, and we tried to illustrate the various types of flaws with some illustrations there, hopefully these demonstrations will make that even more meaningful for you. To get started, I'm going to be taking a look in the Day 3 folder. In the Day 3 folder, you'll find that we have some information that will take you to a web application that you could use if you wanted to reproduce this on your own. Now again, you do not have to do this yourself, but if you wanted to, you can find the application I'm about to demonstrate at 512app.enclaveforensics.com, and we have credentials that you can use, 512 student with a password of password123. Now, we would very much appreciate it if you do not share this information with other people. It's much less that it's secret, much more that we have put a vulnerable application out here specifically to demonstrate a variety of flaws that OWASP details, and we don't want other people tinkering with the application because, of course, it's vulnerable. In any event, to do our testing, I'm also going to make use of another tool. The tool I'm going to use is called Burp Suite. Burp Suite is probably the most widely used vulnerability and penetration testing tool by people who do web application assessments. In fact, many would agree that if you wanted to find 50% of vulnerabilities in your web applications today, you would need to run every automated scanner on the market. And that's only going to get you halfway there. If you, of course, are running off-the-shelf web applications like WordPress, those scanners will do just fine. What I'm talking about are applications that have been custom built for you, either by third parties or by your own developers. In those cases, those tools are going to do the best they can, but they're not going to have signatures for your applications that can identify logic flaws and other problems that a web application pen tester or a hacker would immediately identify as serious problems. Most pen testers use this tool because it gives you both a really easy way to get to the underpinnings of the web application, the HTTP and HTML stuff that we talked about in our class, but it also allows me to automate attacks and has an excellent vulnerability scanner built in. Now, Portswigger, the organization that puts this out, does have a demonstration version, which I'll be using for the class. I elected not to use my professional license for the demonstration because if you chose to reproduce this, we want it to be as close to what we have in the video here as possible. I can absolutely assure you, though, that if we did this with the professional license that I have, the test would go much more quickly, and the vulnerability scanner that's built in would also be alerting us to other findings, the very things we're going to come across, but automating much of that work for me. To use this tool, you may notice that the last few letters of its file extension are JAR, so this is a Java file. That's quite good for us because I can use this on all platforms where Java is supported, but it does mean that I do have to install Java. Now, I don't have that installed yet, so I'm going to start up Internet Explorer. Of course, you can see I'm using Windows 10 here, and if you would prefer to use the Edge browser, you are welcome to do that. But I will warn you that I have seen some significant issues when it comes to using Edge with a variety of tools, least of which is Burp. So I'll prefer to use Internet Explorer. You could use Chrome, Firefox, Opera. Any of those will work just fine. To get Java, I'll simply go to, well, actually I should put it here in the web bar. I will go to java.com, at which point I can do the free download, which will go deceptively quickly, because the free download really is just getting me the tool that will download and install the rest of Java. I'll go ahead and let that get going. And no, I'll leave the destination folder alone. If you happen to do this yourself, during the install of Java, you will notice that one of the things it asks you is if it's okay to install a Yahoo bar and all this other stuff, or actually in this case, Amazon Assistant. I personally do not need any additional plugins in my browser. I am sick of all that adware, so you may want to turn that off, and we'll simply let it do its thing. Now at this point, I'm going to pause the recording, and we will pick up again after Java has completed installing. As you can see, Java has completed installing. Close up that window, and I don't need to do any verification. Let me move that out of the way. And instead, I'll bring my desktop back up, and I should now be able to double-click on Burp Suite, and we can see it start up. Close this window. Gives me a license agreement. I'm not going to submit anything. I'll accept that. When Burp first starts up, it does or is designed for people who do penetration testing and vulnerability assessment. So for that reason, these days it's designed around this project management sort of focus, which is quite nice. But for us, we're just going to use a temporary project. I'll just click Next, and I'll start it up with all of its defaults. Now while that's starting, I'm going to bring my web browser to the front because we actually need to make a small change. The change that we need to make here is to tell our web browser to use Burp in order to make all of its connections to the internet. In order to do that, we're going to go into the Connections tab under LAN Settings and tell it to use a proxy server. And I'll tell it to use the local machine 127.0.0.1, and Burp runs on port 8080. And I will click OK. And OK once again. Now again, if you're just watching, please do not reconfigure your browser this way, because if you do and you don't install Burp, or if you do and Burp's not running, you're not going to be able to do anything with the internet. I'm just going through step by step, just in case you'd like to reproduce this. Now that that's set up, I'm going to switch into Burp here and look under the Proxy tab, because there's actually a default setting that can be somewhat irritating. The default setting is that Burp will intercept every request that is attempted through the web browser. That's good, but it also means that I'm not going to see any results until I deal with it in Burp. And I don't want to start out that way. So I will turn the intercept off for now, though I assure you we will come back and turn that back on later on during our demonstration. Let me just make this window a little bit bigger, bring Internet Explorer back up, and let's try to go to the application for our class, 512app.enclaveforensics.com. There it is. So we're now connected to Acme International. This application has a variety of pieces of information in it. Some of it are files that have been uploaded, there's patient records. The thing we were trying to do was create a situation where there's actual PII that people would care about. But at this point, what we'd really like to do is illustrate the kinds of flaws that you can find within a web application, and really the things that OWASP is most focused on. Let's get started. Perhaps we'll just log in first and browse around a little bit, see what our application looks like. I believe that we are a 512 student with a password of password123. We are successfully logged on. I'm going to tell it not to store my password. At this point I can view the Dropbox and I apparently have a file. Wonderful, and I can view that file. It's just a text file. I can see that there's a medical record section, but apparently I don't have the rights to go there. there's an administration section as well, and a section dealing with policies, and the main homepage. Let's start seeing what kinds of bad things are here, and in particular, let's take a look at it in terms of the OWASP Top 10. One of the OWASP Top 10 is this idea of an insecure direct object reference. Now, a direct object reference, if you read the book, means that there's something in the application that's going to be a direct reference to something stored behind the scenes. And I can give you a perfect example of that. Right here, I can see that there's a link to z2usb.pcb.txt. And while I hover over that, I can see the link down in the bottom. But to make that a little bit easier, I think what I'm going to do is click on the link and then switch over to Burp and look at my history. Because I here can see all of the requests that have been made. And the very last request, for me, number 49, is a request to get Dropboxes /2. This brings us to a direct object reference. These days, many of the APIs and applications that we use a representational design called REST, representational state transfer. And part of that is how we format our URLs. This URL here, for instance, is telling me that we're looking at Dropboxes. Well, in fact, if I go back just one more to actually /Dropboxes, the response to that was a list of all of the files in my Dropbox. Here we're looking at Dropboxes 2. Dropboxes /2 is requesting that object, that thing in my Dropbox. You might already be thinking the bad thing that we could try. There are two names for what we're going to do. One is forced browsing. Now you'll find forced browsing referenced in the OWASP Top 10, and it's mentioned in a few different places. It's most particularly referenced with bypassing access controls, but also here with insecure direct object references. You see, I've so far downloaded the, let me try to open that, runs the security can, has completed, where is it? Let me open the folder. All right, there it is. So it downloaded the file. If I try to open it, it's just a text file. I've successfully downloaded that file. That's one I have the right to access. But what if instead of going to /2, I told it to go to /1? Now that one isn't listed as one of my files, but if I select it, oh, it says, oh, there's IRIX license data. Let me open that up. I'll view my folder. There it is. And in fact, we've downloaded some file that belongs to someone else. There are two problems happening here. One is that there's a lack of access control, but the second is direct object access, insecure direct object access. I can look at the URL and determine that, well, if there's a file that's numbered 2, then there's probably one numbered number 1. Doesn't that make sense? It's incremental. There might also be one labeled 3, but in our case, apparently there is no file number 3. Now, I could even go further to test my theory to see if I'm doing this or thinking about it correctly by trying to upload a file. Oh, but apparently I lack the rights. If I had uploaded a file, what I would be looking for is to see if that became resource number 3. That actually brings us to another rather interesting issue. I've already seen that in the Dropbox, I'm able to access other people's stuff by doing forced browsing, directly entering a URL rather than relying on a link, and using direct object browsing. There's also operational security issues with this too, though. For instance, here, we know there are only 2 files. But take something like the medical records section. Now, the medical records section, it says I don't have access to it. And you may see that at the top, it sets my URL to /homes, which is the home page. But if you notice when I hover over that link, the bottom corner shows that this is actually trying to access /patients. Having seen that the Dropboxes are written using these standard kinds of URLs, well, what happens if I try to go to patients /1? Well, now we're accessing confidential information to which we have no access at all. In fact, we shouldn't even be able to access this section of the application. So this is extremely serious. Now, what got us here again? One of that OWASP top 10, direct object browsing, coupled with insecure direct object access, so the security controls, and forced browsing. Now, I don't know if I can edit. No, I'm not allowed to do that. But there is something else I can do. I started to say that there's an operational security issue. This isn't it. I know this is a big security problem, but the operational security issue is we can now determine how many patients are there. Are there 50? No. Are there 10? Well, in this case, I think there's only a few records in this database. Let me see. I don't remember how many there are. It looks like maybe there's 3. Yes, there are 3 patients in there. But think about this in terms of an application facing the internet. If this were your customer login portal, could this perhaps be a way that a competitor could very easily determine how many customers you have, or how many orders you've processed this year or this quarter, based purely on the URL? Now, I'm not going to go further than this with this issue. There are some suggestions in the book covering the OWASP Top 10 under Direct Object Access on ways that we can deal with this problem. Let's continue on for now. I'm going to come back to the main page, and let's look at another issue that exists. I'm going to click the log off link, and I'm going to come back and log in again. When we logged in as, I think it was 512 student and a password of password. Oh, maybe I didn't. Let me try that one more time. Was it 512 student? I thought it was 512 student. I'll go back and look if I need to. Password 123. I just typed the password wrong. Now, I want to go back over to Burp and take a look at how that authentication's happening. So I've once again scrolled all the way to the bottom so I can see where that occurs. In this case, this GET request, this is where it goes and gets the form to show me so I can log on. And this request here, this POST, is where it submits my credentials. Now, if we look inside of the request, you can see here the username and password are in clear text. That is completely expected. But was this sent over a secure channel? Now, asking that question is a little bit different. The values we're seeing here are in clear text because that's how this protocol works. In order to encrypt it, we would then layer this through TLS, or the older SSL. Was this sent over SSL? Well, notice the URL here, HTTP. This was not sent over SSL. So there's yet another issue, an issue of how we're properly safeguarding the application with cryptographic controls. In this case, we're looking at that being applied on the front end. We're sending clear text credentials from the user's client to the server. But it can also be applied on the back end. That's not an easy thing for me to show in this demonstration, so we're not going to try to, but it would have to do with how the data is stored securely. Are there important fields, for instance in those medical records, that would actually have to be encrypted while they're at rest? We're not going to try to look at it in this way, but we can see right now that there is a very significant problem when it comes to secure credentials being used. There are some other issues that are going on here as well. I want to take a look at the subsequent request that comes in on that. And the thing I'm looking for is the session. Now, you may remember from our discussion in our introduction to web applications, we very briefly gave you this idea of sessions. But we did talk about authentication and session management being listed as one of the top 10. It's actually listed as a single issue, though it is such an enormous issue, it should likely be broken out into at least 2. But they are very tightly coupled, so OWASP has chosen to put them together. We've seen so far that the authentication is not happening over a secure channel. That's very poor. We might also want to investigate whether there's account lockouts occurring. In fact, before we continue with the session, let's find that out right now. Let me log off, and let's try to log on several times as 512 student, and I'll put in bad passwords every time. And after we do this, say, 5 or 6 times, we'll try to log in with the valid username and see what happens. And now let's try the right credentials. 512 student, password 123. Well, even if the application developers have claimed that there's a password lockout, clearly there isn't one. And I feel as though, let me just double check here. Let me try some bad data completely. Oh, we have found another problem. Notice that the authentication itself has another issue. When I enter an invalid user, it tells me that user is not valid. But when I enter a valid user, it simply says logon failed. How could I use that? Well, you may remember some of our discussions regarding the security of usernames and how sensitive they are and what could be done if you had a large number of them. Now, our test application, of course, only has a very few usernames, but the larger your application, the more users you have, the better I would be able to farm out usernames. For instance, let's try admin. No. How about administrator? So since the message changed to logon failed, our logon process, our authentication process, has another issue in it. It reveals valid user information. We do not want that to happen. Let's go back to where we paused with regard to the sessions. So I'm going to log on as 512 student one more time, password 123. And once I've logged on, I will again scroll all the way to the bottom, and I'm taking a look now again at what's happening in the session, what I started talking about before. And what I'm noticing is that the session ID is quite small, 85. In fact, the session ID, you would typically want to find a long random value, perhaps not even just a number, maybe something that looks more like this. Although that in this case is not actually a session ID, that's just some encoded data. But this 85, oh, that is not a good sign. Let me show you what we might do with something like that. To do so, I'm going to make one more request in the application. I think I'll click on the Dropbox link. And the only reason I'm doing that is so that there is an additional request that goes into the server using that session ID. With that in place, I am simply going to right-click on this and send it to the intruder. Now, at this point, we're moving from casual investigation to actual attack, and we're going to automate some of this. What's happened here is that the tool is telling me, here are all of the places where I've found that input exists in the application. I'm going to clear that off and focus specifically on the session ID. I'll add that in as something to test, and then in the payload section, I'm simply going to tell it to create or work through a list of numbers. Now obviously, I've chosen to make our application fairly insecure because I want us to be able to find things pretty quickly for the class. In our case, I'm going to tell it to issue through from 60 through 100. I'm going to tell it that it should have at least one digit and no more than 3 with no fractional digits at all. And it says it will look like that. I've chosen a small range here too, just to keep things moving along. One of the challenges with the free version of this tool is that the longer it runs, the slower it becomes. So by limiting the number of tests we run, it will actually perform a little bit better for us. Let me start that up. It gives me the information about the time-limited functionality. Off it goes. And interestingly, we can already see very interesting behavior. Now I'm going to let it go all the way, but I want you to notice that for me as an attacker, I'm looking at these numbers here. I can see different numbers coming back. Now some of them are 1294, but some of them are quite different from that. At this point, I think I'm going to pause the attack, and I'm simply going to sort these by length. If I do that, let me make this a little bit larger. I'm going to look at the response and render it. when I try to render out these, the 1294s, what I'm seeing is that the web service, the application, has told me you're being redirected. And where am I being redirected? Well, if we wanted to, we could look inside of the HTML and find that it's redirecting me here. What's happening is the application has detected I'm trying to do something I shouldn't and saying, no, go to the home page. Yet, we did see other sizes. Down here, we find a number of other sizes. For instance, when we sent a session ID of 60, we get this response back. Now, what's so interesting about this is I can see over here in the right-hand side, if we compare, in the right-hand side I can see my username, but now I see a different username there. What does this mean? What's actually happening? Well, many people think about attacking applications as trying to guess the usernames and passwords, and that can be a very effective attack, but with password lockouts, it's fairly well mitigated. What happens, though, if we don't have a strong session? Is it possible that someone could either sniff it, because we're not running over SSL or TLS, like this application here, or if it's simply weak, again, like this application here, could someone just guess one or brute force one? It is very rare to find an application that is looking for people who are sending invalid sessions and trying to detect if they're trying to guess someone else's. How can we leverage this, though? Well, let's take a look. I'm going to go into the other part of Burp here, back over at the proxy, and under Intercept, I'm going to turn the Intercept on. Now, when I turn the Intercept on, and I then click on, let's say, Dropbox, you see that Burp comes up to the front, giving me an opportunity to modify the request that's being sent. In this case, I'm going to change the session ID from 85 to 60 and forward that packet. When I do that, and we look now in our web browser, you can see our web browser now tells us we are logged on as T. Adams. I wonder if he has any more rights than we did. Let's go to Medical. It again intercepts it because the session ID is actually coming out of a cookie in the browser, and that's set to 85. That's what mine is. Let me one more time change that. And, oh, and there's another request happening. Sorry, there was more than one. And, oh, we find that Tom Adams is not permitted. All right, let's go back to our attack, though, because there were other sizes. I see here another size, 2344. Oh, that's me. That's mine. And here's mine again at 85. But here's another size. Administrator. This is perfect. So administrator appears to be session ID 62. Let's come back over here and click on maybe medical again. And I've already forgotten what the number is. Let's go back and look. Where is it? It was 62. We'll change the session ID to 62 and forward the packet. And, we are now looking at a list of patients. We can then click again. Whoops. And forward that on. And we're now accessing records. But we are accessing the records as administrator. That means we could probably also administer the application and do anything else we wanted to. What led us here was that OWASP issue in the top 10 regarding session IDs. They're not being generated strongly in this case, so I could simply brute force them or guess them or predict them. And the secondary problem that the application is not running over an encrypted channel. So anyone who could run a sniffer would be able to see, capture, and reuse our session IDs, impersonating our users. Quite serious. What other kinds of issues do we have here? Well, let me come out of here and turn the intercept back off. And let's browse down. Get rid of this attack. Let's browse down to the main page again. I'm going to log off. And under authorized user, I'm going to try a very simple test. I'm going to simply put a quotation mark in that logon field. Now when I do that, I get back this error, very disturbing error. The message is telling me something very, very serious has happened. Now, what has happened? Well, it turns out that this application is also vulnerable to SQL injection. SQL injection means that I can manipulate the application's SQL by simply putting in my own arbitrary queries. This particular kind of SQL problem, let me go back to that page, would be more accurately described as a blind SQL injection flaw because I can't actually see the SQL involved. A regular SQL injection, I would see the actual database values. Now, to leverage this, I would have to kind of guess what this might look like. So I'm just going to try a string or two. Let's try this. So let's say A equals A, let's say, okay. Or A equals A, and let's try that. Okay. And I'm in my mind, I have successfully done something. I didn't log on, but notice I no longer got the error. Let's try just a little bit more with that. Or quote A, quote equals. Yes, so I know by entering invalid data here and then restoring it with valid data, I would need to do more work to exploit this, but I know for sure I am going to be able to exploit this with a SQL flaw. What let me do it is simply being able to put in that single quote for a test. Now, it's not that a single quote is the only way to exploit SQL injection. It's just one of the most common ways you can find the flaw. It would allow me to manipulate the database query and potentially get every record out of every table in the database. For instance, so far, we've been able to get at the medical records and the Dropbox information, but we haven't been able to access the users directory yet, the users file. Could it be possible that leveraging this, I might even be able to get it to extract out the user information and show me that? And we're not going to take it that far, we don't need to, but that is an example of SQL injection. This field actually has another flaw too. Remember that when we entered in invalid data, it shows us that data back on the screen. That's actually a sign that this application may also have a cross-site scripting flaw. So let's just try to do this. I'm putting in JavaScript as the user ID. And the JavaScript in this case is simply going to open alert box, or at least try to. When I try to log on, we get that message back. So that means that we have sent this data in. That data is then sent back to us in the web page and rendered on the page, opening up the box. In that case, it's only opening up an alert window, but what if it did something else, like maybe window.open to http google.com. Didn't quite work. It tried to do something, and I can see that all of the data did not show up here. So let's just take a look and see if we can very quickly fix this. I'll look at the view source and see where that came back. All right, and we're looking for the document.open, or for the JavaScript. It should be displayed with no such user. Let's see if we can find that. Oh, I've already gone too far. Let's see. Oh, I don't see the no such user coming back. Oh, there it is. Oh, it did actually fire it back at us, but apparently, maybe I need to have the quotation marks on it, or maybe pop-up windows are blocked on this browser. Let me try it one more time. I'll try putting quotation marks around it. I was hesitant to do that the first time because I already know there's a SQL injection flaw, so this might make it even more unhappy. No, now it worked. It said, hey, pop-up window blocked. Let me allow that. The pop-up window, temporarily disabled, would have been opening up a pop-up to Google. That actually leads us to another problem that this application has. Now, so far, just to enumerate them, we've seen that this application has a SQL injection flaw, a cross-site scripting flaw, I can send script in and have it reflected back to execute. There's another kind of that. It could be that it's stored in the application. For instance, take those file names with the Dropbox. Perhaps I could upload a file with a strange file name that actually contains JavaScript. So when someone else views that file in the browser, it executes the code, a stored or persistent cross-site scripting flaw. We've seen that there's session ID problems. We've seen usernames are displayed, so user ID and session management is broken. We've impersonated users. We've done direct object browsing. We've forced browsed into other records and even other parts of the application. We've seen that SSL is not being used properly. Let me show you just one more. Unprotected redirects and forwards. On the site, I've included a link to visit the partners. And if we hover over that, you can see that the link is going to go to the application and try to use a redirect to somewhere else. And this is actually a built-in part of the application. In our case, it was not going to take you anywhere. The page doesn't actually exist. But what's the purpose of a link like that? Why would we have a redirect or forward link? Well, the reason it exists is that quite frequently we redesign our site and reorganize where the resources are. We might create some kind of a mapping tool or redirection tool so that when a user tries to go to a resource that we used to have that has now been moved somewhere else, maybe because they found it in a search engine or had a bookmark, they will automatically be directed to the new location, or perhaps even the new website. That's not a problem. The problem is when we don't properly validate those. For instance here, if I simply go into the URL bar up here and say I'm going to use homes/redirect equals, or actually redirect ? I'm just mirroring what comes up in the bottom there. URL equals. Now, it looks like it's supposed to take a web page, but what if instead of that, what if I put another website? I'm going to try to put http://www.google.com. And oh, look what happened. Notice that my URL bar has changed to Google. Now you might be focusing on the fact that it's giving me a warning about the certificate, but that would not show up normally. This is being caused by Burp. Remember that Burp is sitting between us and the application, and every request is going to it. So here was the request to redirect us, and here it is redirecting us. It did actually work. And we can prove that if we simply disable the proxy temporarily. So let me come in, Internet Options, Connections, LAN Settings, and I will turn the proxy back off. With that done, I'll simply go back and try that same thing again. I believe that it's, let me hover over it, I believe it's /homes/redirect. Oh, and there it is. http://www.google.com. And yes, indeed, it will send me to Google. Why does that matter, though? Well, what if an attacker discovered that we had an unprotected redirect or forward? By simply crafting a link that includes that, they can redirect us anywhere. Where could they redirect us that would matter? Well, what if they took us in the phishing email, they said, there's been a breach at our site, there's something very important happening, there's a new message for you, there's whatever the urgent thing is, click here to reset your password now, or to log in. Now, many users have been taught that when you're looking at an email, and it claims to be from someone you trust or someone you do business with, if you want to verify whether or not you can trust it, what you might do is hover your mouse over the links in it and see where they go. This is actually bad advice. This is telling people that if it looks okay, it's all right to click on it. And that is very, very bad. The right advice is what hopefully you're teaching people in security training. If you really have an account there and you're concerned, you should open your web browser and go there manually, not to that URL, to that site, and log on. In this case, I have a link. It says that it goes to partners. But what if I did something like this? Let me open up Notepad for just a moment. what if I had created a website, and on that website it had a link? The link, now the way that would be written is like this. There would be an ahref, an anchor tag pointing to somewhere. That link will be, or this is in the email, http://512app.enclaveforensics.com/homes/redirect $URL equals. So what the email is saying, it is urgent that you log on now. So we have convinced you. Click here. Now actually the click here would be in a slightly different location. Let me move it so that the website is better formatted. It would actually come after the URL. It would be there. So everything between the A and the /A, that would represent an anchor tag. You may recall that from our discussion with the brief overview of HTML and HTTP. The question is, what do I put here? What if I put evil site that cloned Enclave Forensics site.com? What if I did that? The user now looking at this email hovers his mouse over it and sees that apparently this really goes to enclaveforensics.com. So he says, all right, this merely must be from them. He clicks on that link and it really does go there. It goes there to this application and tells that application to redirect his browser to here. Now, if that evil site has actually cloned the site, simply copied all of the resources in the layout, could they now pop open a logon page that looks exactly like ours? But when they type the credentials in, it's not coming to our site. They're now harvesting credentials from our users. I hope that makes sense. It's just one of the ways that unprotected redirects and forwards can be so bad. Generally, if you're going to have a redirect or a forward, it's good practice that it only redirect or forward to your own site or to a known trusted partner. And so unvalidated redirects and forwards is what it's called in the OWASP Top 10. I'm going to stop here for now because this really isn't a class on how to hack web applications. That's not what we're trying to do. And you may have noticed that we even went through some of these issues quite quickly. Now, if you do have questions about it, please feel free to write, or if you're taking the class live, speak to your instructor. The purpose of this, though, is simply to give you a cursory familiarity so that when you're looking at a report, an assessment, and it's telling you that you have, let's say, an unprotected redirect or forward, and you have an engineer or an administrator or a developer saying, oh, there's nothing you could do with that. There's no risk there. You should be able to tell for yourself whether or not that's true. And I hope your answer would be, that is not acceptable. That is a very big risk. These OWASP Top 10 are the top ways that web applications are being compromised and being attacked. Why are they in the top 10? Not just because they're the most common, but also because they're the most serious. So take the time to educate yourself. We hope this video proves useful. If you want to go the extra mile, you're welcome to test out our application yourself. If you do that, I do want to let you know two things. The first is the application will completely reset itself at the top of every hour. So that means it's actually just turned 1 o'clock here, so the application would have just reset itself back to all of the defaults. The administrator user is logged on, T. Adams is logged on, you're not logged on, all the files are in the right place, all the records are in the right place. So if you tinker with the application and make changes to it, they'll reset every hour. So feel free. You can experiment with this if you'd like to. I would also like to ask that you don't try to fully exploit the application. Remember, we've designed this to be flawed. So this is not an invitation to try to hack your way onto that server and get backdoors on it. That is not the purpose of this. Now, I hope you've enjoyed this. If you find it useful, please do let us know. And if there's suggestions on ways that we might refine this video, please let us know that as well. Thank you so much for paying attention.